Okay, so the law of sines. What we're going to be doing today, tomorrow, continue probably on until Thursday a little bit, is we're going to be working with triangles that are not right triangles. Okay? So we learned in the first 4 lessons, we basically focused on right triangles. And in the next 2, we're going to focus on triangles that are not right triangles. And so we can use sine, cosine, and tangent with the right triangles to find all the missing sides, all the missing angles. But if it's not a right triangle, then we have to use either what's called the law of sines or the law of cosines. First of all, let's look at area. When we're talking about the area of a triangle, we know that it's 1/2 base times height. But what if it's not a right triangle? And we're going to talk about one way here in law of sines and another way when we do the law of cosines to be able to find the area of a triangle depending on the information we're given. So in this case here, it gives us 3 different formulas for finding the area of a triangle. But those all are based upon if you know 2 sides and the included angle. Or another way of thinking about it would be, how many of you remember that? Okay. Side angle side, that's right. So if we know side angle side, we can use this formula for finding the area of a triangle. And so you do 1/2 times both sides times the sine of whatever that angle is. But the whole point is that we're looking for side angle side. If you know side angle side, you can find the area of the triangle using this formula. Okay. So here we have this triangle here. They want us to find the area of the triangle rounded to the nearest tenth. So I'm looking for side angle side. Here's a side. Here's my angle. Here's a side. So all I need to do is plug them into that formula. So the area is equal to 1/2 times 5 times 3 times the sine of 40 degrees. And then we just plug that into our calculator. Yep, just plug it into your calculator. If you can see your calculator. Well, maybe not. Oops. Nope. Okay. So what is the answer to that? Hannah? 4.8? Okay. So this is 4.8 square meters. Okay. Square meters. Make sure you put units when you're doing area. Okay. So if we know side angle side, we can use that simple formula, 1/2 times base times the height. And the height is actually determined because if you notice, my height here is found by, we have, for this 40-degree angle, the height is the opposite, and this side here that's 3 is the hypotenuse. Okay. So the height is equal to opposite, or I should say, opposite over hypotenuse is equal to the sine of 40. So 3 times the sine of 40 would be equal to h. So this part right here is equal to the height of that triangle. Okay. So I could make it into a right triangle by saying, okay, 1/2 times the base, which is 5, times the height, which is 3 times the sine of 40. Okay, so that's where that comes in there. That calculates the height for us. Okay. All right, the law of sines. Now, the law of sines here is actually formulated by those three formulas that we used to find area. If we took those three formulas and we simplified them, did a little bit of manipulation, okay, appropriate manipulation, we would end up with the law of sines. Now, make sure that you understand that when there are capital letters, they refer to angles, and lowercase letters refer to sides. And those sides are across from that specific angle. So when it says the sine of A over side A, that means that, if I know angle A, side A is across from it or opposite that angle. Sine of B over side B and sine of C over side C. So law of sines allows us to solve a triangle as long as you know either of the following. As long as I know angle, angle, side, or angle, side, angle, I can use the law of sines. Not side, angle, side. That's only for the area here. We will talk about that with the law of cosines. And then in some situations, you can use SSA. Okay? Now, in geometry, you can't use that. Okay? It doesn't work. So, my theory about the SSA congruence is you can only use it if it applies to you spelled backwards. Okay? Right? That's the only time you can use it. Otherwise, it doesn't work. I didn't say that, you did. Okay? All right, so here we have a triangle, a non-right triangle. So you can't use tangent, you can't use cosine here. Okay? It's a non-right triangle. You can't use sine. You can't say it's just sine of this angle is equal to opposite over hypotenuse. There is no hypotenuse here. Okay? There's a longest side, but it's not a hypotenuse because the hypotenuse has to be the longest side of a right triangle. Okay? So here's what I do when I'm asked to solve a triangle. So first of all, we need to determine what do we know. Okay? So we know here's a side, and then we have an angle here and an angle here. Okay? So what do we call that when we know a side and two angles? Which one of these is it? Okay, angle, angle, side. All right. So I can use, because I know angle, angle, side, I can use the law of sines. First thing I'm going to do is I'm going to rewrite it with the letters that they give me. Okay? So they give me D, E, and F. So the sine of angle D over side D. Sine of angle E over side E. Sine of angle F over side F. That's the first thing I'm going to do is I'm going to write the law of sines using the information they give me as far as labeling. So the next thing that I'm going to do is I'm going to plug in what I know. So I know side D, or angle D is 33. So we have the sine of 33 over, they don't tell me what side D is, so I'll put a lowercase d there. Angle E, do they tell us what angle E is? Actually, they do. Okay, in a roundabout fashion, they do tell us what angle E is because what do we know about the angles of a triangle? Okay, they add up to 180 degrees. So that means then that 33 plus 28 plus angle E is 180 degrees. So to find the measure of angle E, I will do 180 minus 33 minus 28. Which is what? 119? Okay. So we have the sine of 119 over side E, which they don't tell us what that is either. Angle F is 28 degrees. and side F is 15. Now, before we do anything else, okay, can anybody tell me what the longest side in this triangle is going to be? Okay, Maddie, why is it E? Okay, it's not the hypotenuse because it has to be a right triangle. Okay, but that means that, what do you tell me about that angle E? It's the biggest, okay? The longest side is always across from the biggest angle. So when we're done, side F should be the smallest then side D, and then side E. So there's always a way to check yourself by making sure those things apply, that the smallest side is across from the smallest angle, largest side across from the largest angle. So what we're going to do now then is, we all know how to work with proportions, right? All right, we did the warm-up, cross multiply and divide, Mr. Herendeen told us. Okay. So what we're going to do is we're going to set up the ratio that we know with both of the other two. So sine of 33 over D, I'm going to set that equal to the sine of 28 over 15. And since these are all equal, I can put them in any order I want. So then I'll say the sine of 119 over E is equal to the sine of 28 over 15. These are true statements that you can take the one ratio or fraction that I know and set it equal to the other two individually so I can find the missing parts. And so now it's just a matter of doing cross multiplication. We cross multiply, and then as Michael said, then we're going to divide. Okay, I cheated. So side D is approximate, side E is approximate. And in this question, they want us to round to the nearest tenth. How many decimal places in tenths? One decimal place. Okay, so my answer should have one decimal place. So what do we get? Everybody type these in. Make sure you all agree. Okay, 15 sine of 33 divided by the sine of 28. 15 sine of 119 divided by the sine of 28. Type them in your calculator to make sure that you agree. Let's see if mine's working. Nope. Double check your calculator, make sure it's in degrees too. Okay. Letter D. How long is side D then? 17.4. Okay. All right, and how about letter E? 0.9. Okay. 27.9. Okay. All right, do they give me any units on this problem? No, they just have the number there, so I don't need to put units. Okay. So law of sines. Okay. If we know angle, side, angle, if we know angle, angle, side, in some cases, side, side, angle works. All right, we'll take a look at that eventually. All right, let's look at another one here then. Example B. So make sure, one thing you should always do is draw the triangle on your paper. That way you have it right there in front of you. Double check your numbers. Make sure you put them down correctly. They don't have to be perfect. The first thing is I'm going to write it with the angles or with the labels that they give me. Yes? Yep, this is Q. Oops, not theta. Q. Got theta in my mind. Okay. So label it using the labels that they have. Make sure that your sides that are labeled the same as your angles are across from each other. Okay, or under each other. Fill it in. Angle P. Well, they don't tell us what it is, but we can find it, right? So the measure of angle P is equal to what? 105. Is that right, Rachel? Okay. All right. 36 plus 39 is 75. So measure of angle P is 75 degrees. Now remember, we're solving these triangles, which means we have to find all the missing parts. Okay. So when we're done, we should know all three angles and all three sides. So angle P is 75 degrees. No, angle P is 105. I decided to write it down wrong. See if anybody's paying attention. 105 degrees. So sine of 1.105 over 10 equals the sine of 36 over Q equals the sine of 39 over R. And some of you people that like to use capital letters all the time, all right, you can't do that here. Because if you write down that capital B equals 10.5 meters, that would be wrong. Because if it's a capital B, it's got to be an angle. So then what we'll do is we're going to, since we have one ratio that we know, sine of 105 over 10, we know that. So we're going to put that ratio with both of those other two. and we will cross multiply and divide. So 10 sine of 36 equals a q sine of 105. R sine 105 equals 10 sine 39. Cross multiply, and then in both cases we're going to divide by the sine of 105. And when you're done, side P, which is 10, should be your longest side then. If you get that R or Q are longer than 10, then you know you made a mistake. Make sure when you're typing in sine of 36 or sine of 39, you close the parenthesis before you divide by the sine of 105. And here we get 6.1 and 6.5, and those should be close together, considering they're only 3 degrees difference. Make sure you got those numbers. Okay. Now the last part of this is if you have side-side angle. And when we have side-side angle, unfortunately, it's a little bit more difficult then. Because you have to take a look at 3 different things. We have to look at the 2 side lengths, and we have to find the altitude. Okay? This is called the ambiguous case because sometimes you won't have any triangles. Other times you might have 1 triangle, and even sometimes you might have 2 triangles. So if you look down here in this bottom left corner of this chart, okay, it actually shows 2 possible triangles that you could have. So we have a couple of different situations. One is if the angle A is acute. If it's acute and A is less than H, there's no triangle. All right? And H refers to the height of the triangle, or what's called the altitude of the triangle. Okay? The highest point vertically on the triangle. We could have 1 triangle that would be a right triangle if A equals H. There would be 2 triangles if A is greater than H and less than B. And 1 triangle if A is greater than or equal to B. Then if it's obtuse, if A is less than B, there's no triangle. If it's greater than B, then there's 1 triangle. So this is when we know angle A, we know side B and side A. Now H, when it says to find H in this case is equal to, H is if we look at angle A here, okay, we have a right triangle, so H is opposite of the angle over the hypotenuse, so H is equal to B times the sine of angle A. So to find the altitude or the height of the triangle, we have to do B times the sine of A. So to solve a triangle when they give us two sides of an angle, we need to first determine how many triangles there are. After we determine how many triangles there are, then we're going to use the law of sines to solve for the things that we don't know. So here in example 3, they want us to determine the number of triangular banners that can be formed using the measurements A equals 50, B equals 20, and the measure of angle A equals 28 degrees. Then solve the triangles and round to the nearest tenth. So first of all, we have to look, see whether it's acute or obtuse. Okay? 28 degrees, is that acute or obtuse? Okay, it's acute, less than 90 degrees. Right? And here A is larger than B. A is 50, B is 20. So let's look for acute. When is A greater than B? Okay. So if we look down here in the bottom right under the section that's acute, down here, right, it says A is greater than B or equal to B. In that case, we're going to have one triangle. So we can set it up. So we have the side here. Okay, that's our unknown side. That'll always be our unknown side. It says measure of angle A is 28 degrees. Side B is about 20. Side A is 50. So 28 degrees. Here's angle A, side A, side B. So here's angle B, angle C, and side C. So angle A is always this angle here. So I'll always draw it here. So I'll draw a line that I have no idea how long it is. Do my side B with the approximate angle I'm working with. And then draw on the side A. Now, make sure, okay, this is not a right triangle, so you cannot, got that? You cannot use the Pythagorean theorem to find side C. It doesn't work. Okay. So set up the law of sines. Sine of A, 28, divided by 50, equals the sine of B. I don't know angle B, but I do know side B is 20. And I don't know anything about angle C or side C. Now, since I don't know anything about the C's, I've got to find angle B first. Because then once I know two angles, I can find the third angle. So I'm going to work with these two first. 20 times the sine of 28 divided by 50 equals the sine of angle B. Now we're trying to find the angle, right? What did we learn in the last couple lessons about when we're trying to find an angle? What do we have to do? 40? If we know the angle, we say sine of that angle. If I'm trying to find an angle, we do the inverse sine of that then. So what we need to do with our calculator then, which still doesn't like me. Okay, take your calculator. Find this answer here. 20 times the sine of 28 divided by 50. Okay? And that should be a number less than 1. If it's greater than 1, you made a mistake. Okay? All right? It's got to be a number less than 1. So I have 0.18778862251. Is that right? Okay? So that's what sine of B equals. To find angle B, we're going to do the inverse, so second sine of the answer. Right? You could type in 0.1877888 whatever, or you could just hit of the answer. And you should get what? 10.8 degrees. So angle B is approximately 10.8 degrees. So this is 10.8. If we know the angle, we use sine, cosine, or tangent. If we're trying to find the angle, we have to do the inverse. All right, so what's angle C equal to then? Okay, 141.2. All right, that would be 180 minus 28 minus 10.8. So now we'll do sine of 28 over 50, because I know that ratio, so I'm going to use it from the beginning, equals the sine of 141.2 over side C. Okay, so to find the last side then, use the two angles I know and the side. So we get side C, which is going to be the longest side now, right? Okay, because it's across from the longest angle, the largest angle is 66.7. And that is in, doesn't say units. Okay. All right, so there's the use of the law of sines. All right, any questions? All right, I think it's set up so your homework is just each one is only going to be one triangle. So, all right, we'll look at one tomorrow possibly that has two triangles. I can show you how that works. Right, I think the ones you got in your homework are just going to be one triangle.